Hi, let's continue talking about 9.5 and global climate change. Just a quick recap. You got to understand greenhouse effect is super important to life on the planet. There is a naturally occurring greenhouse effect, and there's also a human caused greenhouse effect, both of which deal with greenhouse gases, which are trapping heat in the form of infrared radiation and keeping it at Earth's surface. As we talk about global climate change, we're talking about human caused. So humans adding more greenhouse gases to the atmosphere and warming things up at a very rapid pace. Again, just reviewing from 9.3 and 9.4, major greenhouse gases: water vapor, carbon dioxide, ozone, methane, nitrous oxide, chlorofluorocarbons, and something called HCFCs, halogenated chlorofluorocarbons. These are your major greenhouse gases. Yes, you definitely should know them. You should also know where they come from or what human activities produce them. And we're going to be talking about all these human activities all year long. I went through all of this in a previous video for 9.3 and 9.4. So let's move on and talk about impacts. Oops. Before I get into the impacts, nothing that you need to memorize here. I just want you to understand we have an intergovernmental panel on climate change, the IPCC. They put out reports periodically, and they've stated relatively recently-ish that if we continue warming the planet another 1.5 degrees, then major impacts worldwide. We have got to reduce the warming. How do we reduce warming? We reduce greenhouse gas emissions. Easier said than done. All right, let's talk impacts. Like, what does all this mean? I'm just going to skip over that for sake of time. So let's first look at impacts in the Arctic, in the northern hemisphere, the far north. Permafrost, permanently frozen ground that you find in the tundra in the Arctic. This permafrost, permanently frozen ground, permanently frozen soil, it's going to start to melt because it's no longer permanently frozen because it's so warm. Any settlements, little towns that are built in the far north, like these are usually small native villages, as that ground thaws and defrosts, there's going to be shifts in the ground. So that means that buildings that are constructed are going to become structurally, what's the word here? Falling apart. So clearly some human impacts here. A non-human impact that is important to know. Permafrost traps methane, and it sequesters that methane away and kind of keeps it out of the atmosphere, and that methane stays in the permanently frozen soil. But permanently frozen soil, not accurate anymore. It's not really permanent. So when that permafrost melts, it releases that methane, and that methane goes into the atmosphere. You should know methane is a greenhouse gas. It traps heat. So the permafrost melts, it releases methane that was trapped inside of it as like little methane bubbles, and now we have more methane in the atmosphere. That's going to warm things up even more, which is going to speed up the melting process. As the permafrost melts even faster, it's going to release even more methane, warming things up even more. So we're building this feedback loop. A feedback, or I should say, there's two types of feedback loops, positive and negative. And this one is a positive feedback loop. Like, positive in this case doesn't mean good. It just means we're pushing the system further in one direction. So think about this. The permafrost melts, and as it melts, it's releasing methane into the atmosphere. Methane, being a greenhouse gas, makes things even hotter. As the air gets even warmer, it's going to melt even more permafrost, which is then going to release even more methane. That's the positive feedback loop. We're pushing things further in one direction. A negative feedback loop will bring the ecosystem back to equilibrium or back to normal. A good non-environmental example of a negative feedback loop would be your air conditioning. You set your thermostat for, let's say, 74 degrees. And then during the day, let's say you have your blinds open or your curtains open and the sun is shining through the windows at your house and heating the air up in your house, and your house becomes warmer than 74 degrees. Your air conditioning will then click on and cool the house back down to 74. So that is an example of a negative feedback loop, bringing the system back to normal or equilibrium, whatever that was. So back to permafrost in the Arctic. Huge, concerning problem with melting permafrost. Still in the Arctic, not only is the permafrost, the permanently frozen soil, melting, the snow and the ice are melting. Why is that significant? Well, that's going to affect water supplies because, let's say that all the glaciers were to melt in the next 100 years or so. That's going to have a big hit on water supplies because glaciers, as they melt, that melt water and snow, that melt water does supply a lot of drinking water. As we are losing snow and ice, we are exposing more ground. Think of the snow that would be laying on top of the ground. And that affects something called albedo. Albedo means how reflective a surface is. Snow and ice have very high albedo. They are very reflective. Sunlight, bounces off of them. Dark surfaces like soil or the dark ocean water, or even asphalt, concrete, they are dark in color, and so they absorb a lot of that heat. So what that means, if I have less ice and snow, instead of the land being covered by snow, the snow is gone, and now we just have soil, let's say. So now that soil, having a low albedo, low reflectivity, that soil is going to absorb a lot of heat. As that soil heats up, it's going to melt even more snow and ice and things like that, and then exposing even more dark surfaces, which are then going to absorb even more heat and melt even more snow and ice. Think about what type of feedback loop that would be, positive or negative. I'll give you a moment. It's a positive feedback loop, pushing the system further in in another direction. Another impact in the Arctic, focusing here on animals, polar bear problems. Just gave you that general list or terminology here, polar bear problems. Polar bears rely on a type of ice called sea ice, or more specifically pack ice, that forms at the edge of a continent. Polar bears need that ice to hunt. The favorite prey of a polar bear are seals. And so polar bears will walk on the ice, and from one big piece of ice to another. This ice is nice and flat usually. That picture's not sea ice necessarily. But polar bears will walk across that sea ice and look for little cracks in the ice. And that crack is likely going to be where a seal will poke his or her head up through that crack and take a breath, because seals are mammals and they need to breathe air. And the polar bear will be, patiently waiting on the ice at that little hole, and then they can grab the seal. So what's happening as the ice is melting away, it's making it way more difficult for polar bears to successfully hunt seals. There's more water now, not as much ice. And if you're a polar bear trying to go after a seal, and you're both swimming in the ocean, the seal has a huge advantage at that point. So this is causing polar bears to resort to eating other things, which usually means polar bears are moving into areas where they typically aren't found, and they're encroaching on a lot of human settlements and, raiding dumpsters and eating, trying to attack like small children and dogs and stuff like that. So polar bears are losing a major food source because of the lack of ice. And then lastly here, another huge impact of melting things is sea level rise. Please understand the concept of thermal expansion. Water does expand a little bit as it heats up. Much of the current sea level rise that we experience is due to thermal expansion, and not so much melting ice, but rather thermal expansion. As the water heats up, it takes up more space, there's more volume. However, when we're talking about ice, it is important to notice the distinction between ice on land that is melting and ice that is already in the ocean and melting. If the ice is already in the ocean and it melts, that doesn't change sea level because that ice has already displaced the water away. So any ice, huge icebergs that are floating in the ocean, if those huge icebergs melt, it's not going to change sea level because they're already in the water. Fill up a glass at your house all the way to the top with some water and some ice. As the ice melts, that water level isn't going to change because the ice was already in it. However, if we're talking about ice that is on land, in the form of a big glacier, as that water melts, it's going to eventually go through some watersheds and make its way down to the ocean or maybe to a lake. And that is what's going to cause an increase in sea level. So who cares if sea level rises? Well, look at this last bullet here. Erosion, flooding, saltwater intrusion. We'll talk about that in a later chapter, or you can look it up. So yeah, these are some big problems here. Whoops. This graph here showing months of the year on the x-axis. Y-axis is showing the sea ice extent measured in kilometers squared. And you can see 2020, the red line, that is one of the lowest sea ice that we've had in a very, very long time. That's, again, not looking so great for things like polar bears. This map here, bringing it back to Florida for a minute, the red areas will be flooded if sea level rises by about 3 feet, 1 meter. Think about where we are. What does that mean for us? Things to think about. So there are other impacts of global warming and global climate change and all that jazz, and I'm going to have to get to that in one more video. So we're going to wrap it up for now. If you have questions about changes in the Arctic or anything about polar bears, or if you want me to talk to you about saltwater intrusion that I mentioned over here, just let me know and we can talk about it. So ta-ta for now.